Good morning. Today we will discuss about error and accuracy and its numerical problems. So myself Bala from GPC Kuni Mashra. So first term is in the error, it is measurement. So when we are doing any type of measurement, there is some error involved during the measurement. So first we need to understand what is measurement. First, nature of measurement. The measurements are trial to determine the true value of a particular physical quantity. So the difference between true value of a physical quantity and value obtained in the measurement is called error. If there is some difference between the true value of that physical quantity and its measured value, the difference between these two is called error. So let us take one example. If the actual mass of a body is 60 kg, while the weighing machine measure its mass to be 59 kg, so the error involved during this measurement is 60 minus 59 is equal to 1 kg. So next we will discuss that measurement depends upon many factors. So no measurement can be absolutely accurate. There will be some sort of error in a measurement. Like we take three examples here. First one is the example of the scale, second is Vernier caliper, and third is screw gauge. If we want to measure the thickness of anything or length, then suppose its length is 1.5, it is up to 1 decimal point only, so it is 1.5 centimeter. While doing the same measurement with Vernier caliper, it will give us up to 2 digits after this decimal. So instead of 1.5, it can give 1.52 centimeter. So here one thing to be noted that it is up to 1 decimal. With scale we can measure up to 1 decimal point, but with the Vernier caliper we can measure up to 2 decimal point, and screw gauge is the further precise and accurate as compared to Vernier caliper. It can measure up to 3 decimal point. So if we take the error between these scale, this quantity and the measurement with this screw gauge, then there is some error involved here. So error depends mainly on the system, which type of system we are using for the measurement. So there are two types of mainly error involved during the measurement of any physical quantity. First one is systematic error and second one is a random error. So what is systematic error? The systematic errors are the cumulative error that can be compensated for if the errors are known. So the systematic error we can include in the final measurement. So we can assign that this is systematic error during this measurement if the errors are known, if we know what is the reason behind that error. So here we take the example of screw gauge. If there are two scales, this is mean scale and this is circular scale. If the datum line is not matching with this 0, then there is some error involved during this measurement. So the 0 error is minus 0.03 here, because there are 3 lines behind 0. So all measurements should be increased by 0.03 mm. If 0 is below this datum line, then the 0 error is 0.03 and all the measurements should be reduced by 0.03 mm because it is measuring more. as compared to 0. So this type of error is an example of systematic error which is arising because of the system, because of the instrument which is used for the measurement of any physical quantity. This is the example of screw gauge. If 0 of the datum line is not matching with the 0 of circular scale, then there is some error involved in this measurement. Second type of example for the systematic error, it is the systematic error in the measurement, it results from an incorrect position of 0 point or known as zero error, as we described previously, that the starting point of this voltmeter is not at point 0. So this type of error is called zero error. If the starting point is not matching with 0, then there is some error involved here. That type of error is called zero error, and it comes under the title of systematic error. Next type of systematic error in the measurement result from an incorrect position of 0 point, which we already discussed. It is also called zero error, and incorrect calibration of the measuring instrument. If we didn't calibrate properly the measuring instrument, then there is some error involved. That error is also called systematic error. So the systematic error always occur with the same value when we continue to use the same instrument in the same way. So there is some error with this particular instrument. So we need to reduce all the measurement by 0.03 mm. Second type of error involved is major type of error is a random error. So the random error occur due to mistake made when making measurement, either through incorrect positioning of eye or the instrument. So it will produce a different error every time when we repeat the experiment. They may vary from the observation to observation. So the meaning of these lines is that if we are making any measurement with the same instrument, but we repeat that experiment a number of times, then in each measurement there is different type of error involved. That type of error is called random error because it occurred by chance. So you measure the mass of a ring 3 times using the same balance and get slightly different values, like here I have written values 17.46 gram, 17.42 gram and 17.44 gram. So with the same balance, but we are measuring in number of times, here 3 times, so we are getting a slight different values. So the error involved here is called random error. So next, how we can minimize the random error? Like we can add systematic error in the final measurement or subtract. So random error can also be minimized by repeating the measurement several times. A number of times, how many times we can repeat? Like here we are repeating experiment 3 times and taking the average or mean value of the readings. So a random error can be minimized by taking a measurement several times first and then taking the average or mean value of that readings. Suppose you measure the mass of a ring 3 times using the same balance and getting slightly different values like 17.46 gram, 17.42 gram and 17.44 gram. So the average or the mean of all these 3 measurements it is equal to the sum of all 3 divided by the number of measurement. So here the number of measurement is 3. So the sum of all 3 divided by 3, it is equal to 17.44 gram. So this is the average or mean value. So we can easily find the error involved in the first measurement, in the second measurement, or in the third measurement by subtracting from the mean value. So next type of error, random error. Example of the random error is like parallax error. A parallax error is an error which is caused by the incorrect positioning of the eye when reading a measurement. So actual value is here. If we are keeping eye at different position, then there is some error involved in every measurement. That type of error is called parallax error. It is because of incorrect positioning of eye. So if we keep our eye at point C, then it will read the accurate value of that quantity, of that physical quantity. If we are keeping our eye instead of at point C, like at point A, B or D, then it will give different values of error. Here it is giving the value 15.2, which is not correct, and at point B it is giving 15.1, which is also not correct, and at point D it is giving 14.9. So all these measurement A, B and D, there is some error involved in these 3 readings. While if we keep our eye at point C, then this will give us the accurate value of that physical quantity. So we can easily find the error, like at point A the value is 15.2, while the accurate value is 15. So the difference of these two is error. So error is 0.2 ml, and at point B it is 15.1 minus 15.0, it is 0.1 ml, and at point D it is minus 0.1 ml. So these are different type of reading which is involved by taking the different position of a eye. So the one solution for this is that we can take number of readings at different position of eye and then take the mean of that all that readings. So it will give us almost accurate result. Here if someone repeats his reading several times and then takes the average of that of all the results, then he will end up with an answer that is closer to a true value, but repeating the measurement does nothing at all for the first observer, that is at point C. To avoid parallax error, position of a eye must be in line with the reading to be taken as in position C. So C is the accurate reading, while A, B and D, they are not accurate. So how we can avoid parallax error? First, to keep the position of a eye at straight point. Second is to overcome parallax error in the instrument with a scale and a pointer. For example, an ammeter, a mirror is behind that pointer. The correct reading is obtained by making sure that the eye is exactly in front of a pointer. So the reflection of pointer in the mirror is behind it. It is shown here in this figure. If the red pointer and the reflection in the mirror is at same along the same line, then our reading is correct. So we can avoid this parallax type of error. Here is another example. In the left figure and in the right figure, these both are not correct, because we can easily see pointer as well as its reflection. If we are able to see only one line, that is its reflection is below that pointer, then that reading is accurate reading. So next is consistency, accuracy and sensitivity. The consistency of a measuring instrument is its ability to register the same reading when a measurement is repeated. So we can say it is consistent. But if it is giving different type of values with different with the same instrument but the same quantity which we are measuring, then that instrument is not consistent, that measurement is not consistent. So for the consistency, we should get the same reading with the number of times. Second is a set of readings from the identical instrument will have a small relative deviation or no deviation from the mean value. High consistency means small deviation from the mean value. If we are making different type of measurement, like if we are measuring any physical quantity, we are measuring its weight to be 54 kg, next time it is 56 kg and another time it is 57 kg, then the deviation from these three readings is big, so this is called big deviation. So but here the consistency is low. In the second measurement, if we are measuring the same physical quantity and it is giving different type of reading, like first reading is 54 kg, second is 54, third one is 55. So the difference of readings is small, so there is small deviation and it is highly consistent result. So this is more precise result. Next is a deviation is the difference between the measured value and its mean value from the average. So the average reading of the diameter is 3. Suppose the average reading of the diameter is 3.24 and one of reading is 3.26, then the deviation is 3.26 minus 3.24 is equal to 0.02 centimeter. So this is one deviation during the measurement. Next is relative deviation. It is defined by average deviation divided by average value into 100. If we are getting the average deviation, suppose in the last example it is average deviation is 0.02, average value is 3.24, so the relative deviation we can easily calculate with this formula. Next one is example regarding the consistency and precision. So if the diameter of an object which was measured 5 times using Vernier caliper, so there should be 2 digits after the decimal point. The results are 3.14 centimeter, 3.15 centimeter, 3.12 centimeter, 3.09 and 3.05 centimeter. So we need to calculate the relative deviation. So first thing to find the relative deviation is the average diameter. So the average diameter is the sum of all these measurements divided by 5. It will give us 3.11 centimeter. So the average diameter is 3.11 centimeter. Next is absolute or fractional error and percentage error. We know we use plus minus to show an error in the measurement. Suppose I have written 208 plus minus 1 mm. 208 is the true value of that physical quantity, and 1 plus minus represent the error, and 1 is the error. How many number 1. So 1 mm is the error during the measurement of 208. So the first example 208 plus minus 1 mm, it is fairly accurate measurement, while the 2 plus minus 1 mm, it is highly inaccurate measurement, because the error involved is more in the second case as compared to in the first case. Next, we can easily calculate the fractional uncertainty. Depending upon that, we can say that this measurement is accurate or not. So in the first measurement 208 plus minus 1 mm is the absolute uncertainty, and fractional is 1 divided by 208, it is equal to 0.0048 into multiply by 100, it will give us percentage uncertainty. So here the percentage uncertainty is 0.48%. So we can easily calculate with the second measurement, it comes out to be 50%, that is relative or percentage uncertainty. So the second measurement is not accurate as compared to the first one. So the mistakes are on the part of an individual, such as misreading skills, poor arithmetic, computational skills, and the wrongly transferring the raw data to the final report. If there is some error involved, like we are transferring raw data into the final report, we can miss one thing, so it involves some error. So that type of error, all that type of error comes under the systematic. So these are the source of error but are not considered as an experimental error. So the systematic error, it is caused a random set of measurement to be effected in the same way. It is a system or instrument issue. Systematic error mainly result from badly made instrument, poorly calibrated instrument, an instrument having zero error. This type of error we already done, a form of calibration, poorly timed actions, instrument parallax error. And note that the systematic error, they are not reduced by multiple readings. If we are taking number of readings, then systematic error will not reduce, it remains same in the same way. So second type of error is random error. It is due to unpredictable variation in the performance of an instrument or an operator. So random error, they result from vibrations and air convections, misreadings, variation in thickness of a surface being involved, using less sensitive instrument when a more sensitive instrument is available. So like if we are using scale instead of screw gauge, then it will give us random error. And human parallax error. How we can reduce random error? By taking the mean of all the measurement. So random error can be reduced by taking multiple readings first, and then elimination is done by taking the average or mean of all these values. So next one is accuracy. Accuracy is an indication of how close a measurement is to the accepted value indicated by a relative or percentage error in the measurement. An accurate experiment has low systematic error. Next one is precision. Precision is an indication of an agreement among a number of measurements made in the same way indicated by absolute error. A precise experiment has a low random error. So the difference between the accuracy, an accurate experiment should have low systematic error, while a precise experiment should have a low random error. So this is the main difference between the accuracy and precision. So we can reduce random error, we already discussed, by taking multiple readings. And when a series of readings are taken for a measurement, then the arithmetic mean is taken, mean of the reading is taken as the most probable answer. So the greatest deviation from mean is taken as absolute error. So we can combine uncertainty, like to determine the uncertainty of a calculated value for addition and subtraction, we should add absolute uncertainty, and for multiplication and division we should add percentage uncertainty. When we are using exponents, we can multiply percentage uncertainty by the exponent. So in the next few slides I have taken all the examples for the addition, subtraction, multiplication, division and exponents of a physical quantity. How we can calculate the error involved during these measurements. Consider a simple example of a width of a board like 23.2. It is the true value or the mean value, or we can say central value, and plus minus 0.1 is the experimental uncertainty. So we can easily find the percentage uncertainty involved here. It is equal to 0.1 divided by 23.2 into 100, it is equal to 0.4%. So this is the percentage uncertainty involved during this measurement. Next example is 5 measurements are taken to determine the length of a card. So these are different lengths during the measurement. These will give random error. So the values are 209, 210, 209 mm, 210 and 200 mm of a length of a card. So first we need to calculate the mean length of the card, and second find the random error, random uncertainty in the measurement, and third one express the mean length including the absolute uncertainty. So the first mean length is can be find out easily by taking the sum of all the measurement divided by 5. So it is equal to 208 mm. So it gives the mean to the same number of significant figures at the measurement. So the decimal point we can easily neglect while taking only 3 total number of significant figures as that of measurement. Second, we need to calculate the random uncertainty in the measurement. So the random uncertainty is equal to maximum reading of a physical quantity minus the minimum reading divided by number of readings. So the maximum value of a physical quantity is 210, while the minimum is 200, divided by the number of readings is 5. So 10 divided by 5 is 2 mm. Third, we need to calculate the absolute uncertainty. So 208 is the mean, plus minus 2 gives us random uncertainty. So plus minus 2 is an absolute uncertainty involved during this measurement. Next, we can easily calculate if we are adding or subtracting the two quantities, then what are the error involved during this measurement. So if we are adding or subtracting the two physical quantity, then the error involved during this, if we are taking the average error, then delta z is equal to delta x plus delta y plus delta z up to so on. But if we are taking the standard deviation, then delta z is equal to delta x whole square plus delta y whole square up to so on. So there are two type of error involved, average error and standard deviation. Depending upon the measurement are linked with each other, that is correlated with each other or not. If there is some correlation, then we can add linearly. If there is no correlation, then we need to add with the standard deviation. So example for this is